First three, if you could let me review prime factors real fast with you. Remember if we had a number like 32, I could list that in its smallest parts or prime factors by building a tree. 4 times 8, there's a lot of 2's in 32. Break it all the way down until you get to prime numbers. And I like to circle those so I know I've done. So as a product of primes, I could show 32 as 2 times 2 times 2 times 2 times 2. And for today, I do not want you to go like this. All right, I want you to write them out. Now, how does this become valuable today? We're actually going to use square roots to realize that they follow some pretty simple product rules here we can use to simplify a square root, because you can actually take square root of 216 and make it look different, technically simplified. There's a rule that when you have the square root of factors a and b, it's the same thing as splitting them apart into square root of a times square root of b. As in, 12 has the factors 4 and 3, right? It's true that the square root of 12 is the same thing as the square root of 4 times the square root of 3. So this is useful. We can actually think of 12 under one giant radical as 4 times 3. Break it up even further. It's like square root of 2 times 2 times 3. You could also show it like this. Okay, and if you're multiplying two square roots of 2 by each other, what ends up happening is they cancel out and it's just 2. It gets rid of the radical. We can't do anything with the 3, it has no pairs, but square root of 12 can also be shown with a number on the outside, sort of like a constant and a variable. Square root of 3 stays on the inside. Another way to think of it is, when I had it like this, when you have it broken into its primes, grab any pair from the inside, pull out, and put one of the values. Don't put 4, because we're square rooting this. We're basically taking out the square root of 4, okay, and putting it on the outside, because we can. Square root of 4 is 2, and then we have to leave the 3 on the inside. 3 on the inside. You can do this with an even bigger number like square root of 600. Break it into its prime parts in order. Then pull out the pairs. 2 times 2, 5 times 5. So you take a 2 out and a 5 out. Multiply them together. 2 times 5 is 10. 2 times 5 is 10. What do we have left? The 2 and the 3, which then you multiply as well. So square root of 600 is actually 10 square root of 6. Same thing. How do we do this? So you see this problem, you take 216 and you break that down like we did here. We wanted prime parts. So 216, why don't I just do 2 times 108? And I've got that one. And then 2 times 54. 2 times 27. Now I gotta start breaking 27 into 9 and 3, 3 and 3. Put it in order under a radical, because remember it was a square root. 1, 2, 3, 4. 1, 2, 3. Oh, it should only have 3 2's, and then 2 3 3's. Then we pull out the pairs. Here's a pair. Here's a pair. The rest goes back under. We have a 2 and a 3. One more time, and I know someone's going to make this mistake, but notice when I pull out the pair, I do not pull out 2 times 4. I pull out, 2 times 2. I pull out square root of 4, square root of 2 times 2, which is 2. And then same goes for this. If you see the pair, you only write one of them on the outside. That's what it's really worth. 2 times 3 is 6. Under the radical, 2 times 3 is 6. Final answer is 6. Sorry about that. 6 times the square root of 6. So, for practice, pick 3 of the A through I's to show me you kind of know how to do this. Show me the work.